The quadratic formula continues. There's something you need to know. Life's not always rainbows and unicorns. Sometimes you're going to get some radical and complex solutions, just like the quadratic formula. So we're going to do some examples that you need to keep in mind while you're using the quadratic formula. Here we go. 9n squared minus 7n minus 4 equals 0. Let's do this just like we have done in the past. We've got an a value of 9, a b value of negative 7, and a c value of negative 4. Plugging those values into the quadratic formula, we're going to get this guy right here. Let's do some simplifying. That gives us x equals 7 plus or minus square root of 193 divided by 18. Now wait a minute, this 193 doesn't simplify. In fact, we can't even break it down at all. So what do we do with this whole big mess right here? Well, nothing. That's a totally acceptable answer. That would be 7 plus square root of 193 divided by 18, or 7 minus square root of 193 over 18. We can plug that into our calculator and get a decimal approximation, but for our purposes, this is going to be just fine. You can leave your answer just like this with a radical. Moving on, 2x squared minus 4x minus 3 equals 0. So we get our a, b, and our c, we plug it all in. Boom, boom, let's go simplify. That'll give us x equals 4 plus or minus the square root of 40 divided by 4. Now this time, instead of finishing here, we actually can simplify this square root of 40. So let's go ahead and do that. Breaking that 40 down, we can get 2 square root of 10. Now, if you get to this point and you can't simplify, great, you're done. However, I do see that I have a 4 and a 2 in my separate terms here in the numerator. Check this out. Since this 4 and 2 have a 2 in common, I can factor a 2 out, giving me 2 times 2 plus or minus square root of 10 divided by 4. From there, we can see that this 2/4 can simplify out to 1/2. Doing that, we're going to get 2 plus or minus square root of 10 divided by 2. And these 2's cannot cancel each other out because we have this other term attached here. So whenever you could simplify a square root or factor something out and cancel it out, you got to do that because we like to keep things simple as much as we can. This is going to be our final solution set for the equation. And for our final example, 3x squared plus 4x plus 2. And same stuff, different day, a, b, and c, 3, 4, 2, plug it all in. Simplifying, we get x equals negative 4 plus or minus square root of negative 8 over 6. Hold on, square root of a negative. Think back, what does that mean? If this is a square root of a negative, it doesn't exist, it's imaginary. And that square root of negative 8 is going to simplify to 2i to represent the square root of a negative, square root of 2. Always watch out for those complex imaginary solutions. I also noticed that we have a 4 and a 2, so we can factor a 2 out, giving us 2 times negative 2 plus or minus I root 2 over 6. My 2 and my 6 can simplify out. And our final solutions are x equals negative 2 plus I root 2 over 3 and negative 2 minus I root 2 over 3. Well, that's not so bad, Mr. Zonker. You know, maybe you're right. Maybe radical and complex solutions can have rainbows and unicorns after all.